So today we will be discussing about the distributed file system, which is a very important resource management component of distributed system. And we can say that it is also a key component of any distributed computing system. Now, the main function of the distributed file system is to create a common file system that can be shared by all the clients through their individual computers if they are present in the distributed system. Now, this common file system, it is used to store programs as well as the data, and the purpose is to make it available as it is needed by the different clients. Since files can be stored anywhere in the distributed operating system, so it means that the distributed file system should provide the location transparency. So nobody should be able to know where the file is located or where the file is being stored. So regardless of this physical location, anybody can access the file, and to achieve such kind of goal, a distributed file system usually follows the client server model. Now, in the distributed file system, it typically provides two types of services, the file service as well as the directory service. And these services are implemented by file server and the directory server. And these servers are distributed over the network. Now, these two servers can be implemented on a single server as a single server, or it may be different. Now, the purpose of the file server is to provide the operations which is related with the content of the files, such as reading, writing, or making some amendment, appending the file, the content of the file. And the directory server provides the operations such as directory and the file creation, its deletion, for the manipulation of the directory as well as the file names. So before we go into the detail, we have two very important goals which are associated with the distributed system. The first one is the network transparency, and second one is the high availability. These are the primary goals of the distributed file system. The network transparency is a kind of a goal which provides the functional capabilities to access the file which is distributed over a network, because the file can reside at any location. And the users who want to use those files should not be aware about the location of the files for accessing it. This property of the distributed file system is known as network transparency. The second one is the high availability. The meaning of high availability is that whenever a user is in requirement of the file or the information, want to access file, irrespective of its physical location, it should be available to the client. Unavailability used to happen if there is some system failure. Some backups are being taken at the particular time or in the maintenance time. Because of the system failure and the regular schedule activities such as backup or the maintenance, it may be possible that the files may not be available to the user. So with these two goals, that network transparency, whenever the location of the file which any user want to access should not be available, and whenever it is required, to access a file, it should be available. So there are several distributed systems which have been developed, but we will be discussing the most used distributed file system structure. We know that that in distributed file system, the files can be stored at any machine. We are seeing in this architectural diagram, the illustration shows that we have different clients, and these clients are connected with the different servers through the communication network. So normally the files can be stored at any machine, and the computation can be performed on any machine. So when a machine needs to access a file which is stored in a remote location or remotely stored, so the remote machine performs the necessary access operations and returns the information either in the form of a data or in the form of a file if the read operation is being performed by the client. So normally what is done for getting higher performance, we have several machines which are known as file servers, which are dedicated for storing the file and performing the storage as well as the retrieval operations. And rest of the machines present in the system can be used for the computational purposes. So those machines which are used for computational purposes are known as clients, can be referred as clients. And the purpose of these clients is to access the files which are stored at the servers. It may be possible that the client machine will be equipped with the local disk storage. It may be possible, it may not be possible. It may be so, it may not be so. So that whatever remote file which is being accessed from the remote location can be cached onto the client side. Now, as I told you that the two most important services which is available in the distributed file system, such as name server and the cache manager. The name server is a process. Name server is a process that maps the name specified by the client to the stored object. What are the stored objects? It will be either the file or the directory. And this mapping occurs when a process is going to refer a particular file or the directory for the first time. A cache manager is a process that implements the file caching. And you know already that what is the meaning of caching. And in the file caching, the copy of the information is stored in the form of a data or the which is stored at the remote file server is brought to the client machine whenever client has asked for it. And so subsequent accesses of the data are performed locally at the client side. And this operation is going to reduce the delay of the access delays due to the network latency. Because every time whenever client is going to the server and asking for the file, it has to go to the server, and server will be sending that file to the client. Besides that, it is always necessary because it will be taking a lot of time. So it is necessary that whenever client is going to ask, it will be the information which has been sent by the server, it can be cached on the client side. So multiple times whenever it is required, it has not go to the server itself. and just by reducing the delay which happens while accessing the file due to the network latency. We also have cache managers at both client side as well as the server side. And the duty of the cache manager is same function, same whatever it is available at the server side or at the client side. The duty of the cache manager at the server side is to cache the files in the main memory of the server to reduce the delay due to disk latency. And if multiple clients are allowed to cache a file and modify it, the copies are going to be inconsistent. So just to avoid this inconsistency problem, the cache manager of the client side as well as the server side has to have coordination with respect to the performance of the data storage as well as the retrieval operation. So as I told you that we have two kinds of services, that is name server and the cache manager. Name server is going to provide the mapping in between the name which is supplied by the client to those objects which is available in the form of a file. And the cache manager is going to improve the performance through the file caching. Caching can be done on the client side and caching is also done on the server side. So this is the illustration which shows the how accessing of the data take place in the distributed file system. If there is a request by a client to access the data, and if that data, it will first request for the accessing of the data, it will first give its request to the local cache. This local cache is actually the client cache, which is available at the client side on which the process is running. So if the block is available in the cache, it will return to the client. But if it is not present in the cache, so it will going to check the client's local disk. If present in the local disk, the data, it will be loaded to the client cache. But if it is neither present in the client cache nor present in the local disk of the client, then it will send its request to the file server. So at the file server, first of all, through the communication network, the request has been sent. So first of all, the server is going to check its cache for accessing of the data which the client is in requirement. If it is available in the server cache, it will load it into the client cache. But if it is not even available on the server cache, it will go and check its disk. And once it is available on the disk, first of all, it is going to be loaded on the server cache, and then it is going to be loaded on the client's cache, and then data will be available to the client. So in this way, the accessing of the data take place in the distributed system. But before we go into the detail that what are the mechanisms and how the distributed file systems are built, we must know the issues which are associated with the distributed file system, and these issues are called the design issues. The first and the foremost important issue, design issue in the distributed file system, is the naming and the name resolution. The name, as far as the name is concerned, name in the file system is associated with an object, and that object may be a file or the directory. Namespace is a collection of the name which may or may not share an identical resolution mechanism. Namespace is a set of names complying with the given name convention, whether it is a human oriented or system oriented. So whatever convention has been followed or convention is combination of these two. And the name resolution is the process of mapping a name to an object, whatever has been asked by the client and whatever form it is stored on the server. So traditionally, we have three different approaches to name files in the distributed system. And the simplest scheme is to concatenate the name of the host to the name of the file that are stored on the host. Now, this approach is going to give the guarantee that the file name is unique. File name is unique system-wide. But the conflict is going to happen whenever we talk about the network transparency. Because whenever the host name is being added along with the name of the file, it is going to declare where it is located. So network transparency will be not achieved. Another problem which is associated with this approach is that whenever we want to move a file from one host to another host, so what we have to do, we have to make changes in the file name as well as in the applications accessing that file. So this naming scheme is not a scheme which can be called as a location independent, because location independent scheme is that scheme in which file need not to be changed, file name need not to be changed when the file physical storage location changes. But we have advantage of this scheme that as far as the name resolution is very simple, because file can be located without any consultation from the rest of the hosts in the system. The second approach is to mount remote directories onto the local directories. Mounting a remote directories requires that the host of the directory to be known. Once a remote directory is mounted, the files can be transferred in a location transparent manner, thus achieving the location transparency goal. And if the name of the file is not going to reveal the physical storage location, it means it is a location transparent. The advantage with this system is also, one of the advantages, that this approach can also resolve the file name without consulting any host. Now, the third approach is to have a single global directory where all the files belong to a single namespace. But this approach does not have any disadvantage, does not have having any disadvantage with respect to the previous two approaches. But it has that disadvantage, and that is that it is mostly limited to one computing facility if we are adopting the third approach. If the unique file name, system-wide unique file name has been given, so it is able to provide only one computing facility. Or if it is so, it is not so, it is having very few cooperation with the computing facilities. And why it is so? Because the system is in requirement of a unique file name. And whenever a unique file name has been given, that requires all the computing facilities to involve the corporation. So this scheme seems not to be very practical, because it's going to encompass the heterogeneous environment. Heterogeneous environment and the geographical areas through which it is associated. It is a good technique, it is a good scheme, which is suitable only for single computation facility. Single computation facility. So this is about the naming and the name resolution. The second concept is related to the concept of context. The concept of the context is to partition the namespace. Now we have seen that we have a difficulty associated with the system-wide unique names. So the concept of the context has been introduced, which is going to partition the namespace. The context identifies the namespace in which it is going to resolve the given name. And this context can partition a namespace along the geographical boundary, organizational boundary, specific to the host, to the file system type. So in this context-based scheme, file name can be it may be composed of contexts as well as the name of the local name to that context. So resolving a name involves the interpreting the name with respect to the given context. And the interpretation may be complete within a given context or may lead to at another context in which the process, in this way, the process may have to be repeated. So this is an example which is associated with the context, that we have two kinds of logic file system, which involves the context. One is called X kernel logical system. Second one is tied naming scheme. And this, we have a route through which we have divided the different files at the different locations. This is named as text. It means the files which are related with the text file is here, the simulation and the miscellaneous. So the namespace is partitioned based on the properties of the files or the directories. And they are logically independent directories. In this text, we have memos, let, we have a doc, we have journal, books. So this is the actual physical file system, which is going to give the context which is related. This is the context, means the text files are here. This is simulation files are here, miscellaneous files are here. The third part of the naming and the naming resolution design issues is the name server, whose basic purpose is to resolve the naming conventions. And this is the name server which is responsible for the name resolution. And as defined earlier also, the name server is a process which maps the name specified by the client to the stored objects such as file or the directories. You know that in case of centralized system, a table is being maintained which is going to map the names to the objects. Similarly, in distributed system, name servers are responsible for the name resolution. And name server is a process that is going to map the name specified by the client to the stored objects. And the easiest, we have two approaches for that. And the easiest approach to the name resolution in the distributed system is that for all clients sends their queries to a single name server which maps the name to the objects. But this system has the certain drawbacks. Why it is having certain drawback? If the name server is going to crash, the entire system will be surrendered or going to give a drastically affected. Second, the name server is a bottleneck and it is going to reduce the performance of the system. The second approach is which involves several name servers on the different host, and each server is responsible for mapping the objects stored in the different domains. This approach is commonly used in distributed system nowadays. And whenever a name is to be mapped to an object which is given by the client, the local name server, which is nothing but it is which is maintaining a table in the kernel, it is being queried first. If the local name server, and this local name server is going to point to the remote name server for further mapping of the name. For example, if we want to query for /A/B/C, it may require a remote server for mapping /B and /C as the part of the file name. And this process is being repeated till the name is completely resolved to get /A/B/C. To get higher performance, better performance, fault tolerant, we have to do one more thing, that we have to replicate these tables which are used by the name servers to the different servers. The second design issue with the distributed file system is the cache. You know, caching is a very commonly employed in the distributed system just to reduce the delay while accessing the data from the server. In file caching, the copy of the stored data which is available at the remote file server is brought to the client, and whenever the client has requested for that, and subsequent access of the data is being performed locally by the client. So once it is available at the client, it can be successively accessed by the client itself. Now the process of doing the caching, whether to do the cache on the disk or to the main memory, is the main fundamental issue. So first of all, let us go with we want to, since either of main memory or the local disk can be used to cache the information, let us see the advantage and disadvantage of one over the other. If we are doing the cache, if we are utilizing main memory for using it as a cache, the first advantage which we will be getting, that in most of the cases we have diskless workstation. So in that, if the workstation on the client side is diskless, it is going to give the advantage of caching on the in the main memory. The second advantage is it is faster than the local disk. If we are using cache in the main memory, since accessing of the main memory is faster than accessing the local disk, so thereby accessing of the cache of the main memory will be faster than accessing the cache of the local disk. And the third one is server cache. Server is also having cache, and which is stored in the main, and the main memory is used for the cache purpose. If server is designed, if server cache is in the main memory, so we have to use only single design if we want to implement client cache in the main memory. So the same design, single design, can be used, can be applied for the client side also. Otherwise, if server is using cache in the main memory and client is using disk on the client is using cache on the disk, then we have to apply different mechanism for accessing the cache. But since server is using cache in the main memory, so the one design, single design is going to be implemented. So these are the three advantages of having cache in the main memory. But there are certain disadvantages also. If we are using main memory as a cache, then it is going to compete with the virtual memory system for the physical memory space. Because the same memory space can also be used in the physical memory space, it may be used as a virtual memory space. Therefore, a scheme to deal with the memory contention will be required, will be necessary in between the cache and the virtual memory system. And this scheme will also prevent the data block from being present in both the virtual memory as well as in the cache. So consequence will be that we have a complex cache manager, we have complex memory management system. A limitation of caching in the main memory is that limitation of caching the using main memory as the cache, that we cannot store large files in the cache because the size of the cache is very limited. So what we can do the caching in the form of a blocks, not the whole file, but the block. But this block oriented caching scheme is also very complex, and it is going to impose load on the file servers. Why it is going to impose load on the file servers? Because every time we are caching only the blocks. So one block is required, second block is required. So it is very much similar to the concept without using cache, directly accessing the server itself. But we have certain advantages of if we are doing the caching on the local disk. This disadvantage of caching the main memory can be removed if we have to store the large files, because large file can be easily cached in the local disk without affecting the performance of the system. And virtual memory system is also very simple in that case. One more advantage if we are using the disk space as a cache, that the portability and non-portability. If the client who is working and he has to make the system portable, he has to take away, disconnect from the network and keep it itself from away and use the system somewhere else. So what he will do, it will cache the information in the form of a file into his local disk, disconnect the system from the network and take it away. And the information is available in the cache. So whatever is the required file, it is available in the cache of the local disk.